Hi guys, so the first video of this week is solving the system of equations using all three methods. Okay, so keep in mind that we've learned three different ways, and while they seem different, they're all doing the same thing. We're looking for a point of intersection. When we're solving a system, we're looking for some point of intersection where x and y are the same. Okay, so the first way we learned was solving by graphing. And no matter which method I'm doing, I need to make sure to number my equations. So I have equation 1. And I have equation 2. Alright, so when we are solving by graphing, we need to make sure both equations are in slope-intercept form. Okay, and right now they're not. If I look here, my y is still next to some other thing, so I need to rearrange them. Alright, so how do we rearrange them? We use inverse operations. So I'm going to subtract 3x on both sides. And I'm left with y equals negative 3x minus 7. Okay, nothing's in front of the y, so I'm good. The next one, I subtract 7x on both sides. I'm left with negative 2y equals negative 7x minus 12. And this time I have to divide because there is still a coefficient in front of the y. And I'm left with 3.5x, or I can leave it as 7 over 2x plus 6. Either one of those is okay. All right, so our new equations that we want to use are these equations 1 and equation 2, the simplified version. All right, so what I'm going to do is the first one, I went ahead and plugged this into my calculator. And when I plugged it into my calculator, I looked at the table. And if you notice, my graph is small. It only goes to negative 5 and positive 5. So I just picked some points from my calculator that actually fit. So negative 4, 5, negative 3, 2, negative 2, negative 1, and negative 1, negative 4. All the other coordinates are too big for my graph. So and we know based off here, our slope, the graph is going down 3 spaces over 1. Okay, so that's equation 1. Make sure you are labeling. All right, equation 2. Same thing. I plugged it in my calculator and I figured out some points that match. Okay, so for this one on my calculator, I saw that negative 4 was negative 8. That one's too big for my graph. Okay, so there's only a few points we can fit on here. So negative 3, 4.5, negative 2, negative 1, and negative 1, and negative 2.5. That doesn't make sense. Oh. This should be a positive 2.5. Oh, Miss Mish is making a lot of mistakes here. Okay, so first of all, oh no! Sorry guys, doing this on a Monday morning. Alright, so first of all, the first point was negative 3, negative 4.5, that's down here. The second point is negative 2, negative 1, and the last point is negative 1, positive. There we go. Okay, so let me relabel. This was equation 2, this is equation 1. Okay, and our point of intersection is our solution. And we can see that point on both of our tables as well. So the solution to the system is -2, -1. Okay, next method, solving by substitution. In order to solve by substitution, we need one variable isolated. Okay, so I have equation 1 and equation 2. 3x plus y equals -7. 7x minus 2y equals -12. Okay, and I asked myself, is one isolated? No, but this one almost is. Okay, so just like we did with the graphing, I want to get the y by itself, just because that looks super easy to get alone. So I'm left with y equals -3x minus 7. Great. So now we have one that's by itself. That's the one that I'm going to star. Okay, so now I'm going to take that y and I'm going to substitute it in. So now I have 7x minus 2 times y equals -12. There's not a lot of room in here. Okay, so now let's go ahead and solve that. I'm going to try to make some more room down here. Let me erase that. All right, so 7x minus 2 parentheses -3x minus 7 equals -12. All right, let's solve. So I have to do distributive property first. Bring it down. Combine my like terms. All right, now inverse. Okay, now what do we do with that? We're not done. We still need a y. So I go back to my starred equation. I go back to this equation. And now instead of x, I'm going to replace it with the number we found, which was -2. And I get 6 minus 7, which is equal to -1. And I check, and it should be the same exact answer that I got when I did it by graphing. And it is. Okay. All right, the last one we learned was elimination. So, with elimination, we need like terms lined up. Okay, we also need matching coefficients. So, I look at these two equations. Let me zoom in. Okay, let's say I want to eliminate my y's. Okay, this has a coefficient of 1, so I multiply my second one by 1. This has a coefficient of -2, so that's what I'm going to multiply the first one by. Remember, it's always opposite. Okay, so now that we've identified our coefficients, we're going to go ahead and use the distributive property to create new equations. So I have -6x minus 2y equals -7. Oh, not -7. Positive 14. And the next one I'm multiplying by 1, so it just stays the same. All right, but we need one of our equations to be opposite. So I'm going to just change all my signs. This was a positive. Now I'm going to make it a negative. This was a negative. Now I'm going to make it a positive. This was also negative. Now I'm going to make it a positive. So now I check my y's. Are they opposite signs? Yes. Are they the same coefficient? Also yes. Okay, I'm trying to... I know this video is getting pretty long, so I'm going to try to speed it up. All right, let's combine. I have negative 13x. These eliminate. Equals 26. And we already know that our answer should be negative 2. Good. All right, and then how do I get y? I need to substitute again. I need to go back to an original. So an original, 3x plus 1y equals negative 7. And instead of x, I'm plugging in negative 2. So I know this seems really tedious, and why do it all 3 ways if we already got the answer? But on your quiz tomorrow, we need to make sure we know how to solve using all 3 ways. On your project, at the end of the unit, you will also need to know how to solve all 3 ways. Okay? Based on solving all 3 methods, what do you notice? What is your conclusion? So the answer is the same for all 3 methods. If you have any questions, please make sure to answer the next question at the end of the video. See you tomorrow.